And today we're going to talk about absolute value equations and, along with those, some inequalities. But everything that we do today will have absolute value in it. Okay, and we know the symbol for absolute value would be something like that. Okay, our two vertical bars. And if we were to do a real basic one, okay, absolute value of x equals 2, then when we talk about absolute value, definition of absolute value, you may remember what the definition of absolute value is. Distance away from zero, okay? So really all we're asking ourselves here, just so you kind of understand what's going on here, is what numbers are 2 units away from 0, right? And so we could say positive 2 or negative 2. So those would be the two things that would make this work. And that's why, so on this one I could say plus or minus 2. But that's why when I take the absolute value of a positive, it stays positive, and when I take the absolute value of a negative, it becomes positive, because distance always is positive. Okay, one thing you're going to have to really watch out for today is if I were to give you one like this, anytime absolute value is by itself and is equal to a negative, then we will say no solution. There's no number I can plug into the absolute value here that would make that equal negative 3. If I plug in 3, it's a positive 3. If I plug in negative 3, it's also a positive 3. So no numbers would make that work. The only way that make that work would have, you'd have to have a negative on the outside of the absolute value, which means absolute value is not by itself. Okay, so just a couple of things to kind of lead into what we're going to be doing today, but this is something we're going to have to really watch out for because we're not necessarily going to notice it right at the beginning. As we start solving these inequalities or equations, first of all, then when I look at it, it may not be equal to a negative right away. But as I start solving it and I start getting absolute value by itself, does it ever equal a negative with absolute value by itself? And so that's something you really want to kind of keep in the back of your mind. Once again, I'll kind of go back to the point where we can check these, right? We can take a number that I get, I can plug it back in for x, and I can see if it works. And if it does, that's a pretty good feeling. And if it doesn't, then we got to figure out what did I do wrong, okay? And so I keep saying that because next week on the test, a lot of the problems that we're going to be doing are things that you can check. Any solving problem, you can always plug it back into the equation and see if it works. So you shouldn't have to wait for me to grade a test, right? Because you know, hey, I already checked it. I know that problem is right. Okay, so we're going to start off with equations. I'm going to do a bunch of different types of equations, show you some different things that we could do. This one, once again, it's pretty basic. Absolute value of 8x equals 24. As long as there's nothing on the outside of the absolute value, then immediately we're going to make two equations every time. Okay, and so what we're going to start with here is we're going to say 8x equals 24. And we're going to say 8x equals negative 24. Because positive 24 and negative 24 are the two things I could put into this absolute value that would make it equal 24, right? But we want to find out what value of x makes that true. And so on this one here, we would divide by 8. And then we divide by 8 again. And those would be our two solutions. Okay, I will tell you that it's not always going to be the same number with the opposite sign. Okay, so if you want, on this one, if you wanted to, you could write it like that. But in most cases today, you won't be able to write it like that. So you're just going to have to write it as two separate answers. Absolute value of 3x plus 2 equals 1. Okay, once again, in just a second, we're going to look at some that have something on the outside of the absolute value. This one does not. So once the absolute value is by itself, which is already the case, then what we have to remember is on all of these, we're going to set it equal to 1, and we're going to set it equal to negative 1. So we're going to write two equations out. The only situation where you won't do that is if I have a negative here, there would be no solution. If this is 0, there's no such thing as plus and minus 0, right? So that would be the one time we couldn't do two equations. But as long as we have a positive number there, I'll always do the positive and I'll always do the negative that it's equal to. And then we're just going to solve those two equations out. So x equals negative 1/3. We subtract 2 again. And x equals negative 1. So those would be our two answers. Okay. And I'm not going to check every single one of these just for the sake of saving a little bit of time, but you can always take these two, you can plug it back in for x, and just verify that it gives you positive 1, right? Negative 1/3 times 3 would be negative 1. Negative 1 plus 2 is 1. Absolute value of 1 is 1. If I plugged in a negative 1, 3 times negative 1 is negative 3, plus 2 would be negative 1. But when I take the absolute value of negative 1, it gets me back to 1. So both of those check. You don't necessarily have to show me that you checked it, but it's just really for your benefit to know that both of those answers work. Okay. All right. Now, on this next one here, absolute value of 2x minus 1 minus 5 equals negative 3. Hey, and what happens is a lot of times people see this negative 3 over here and they think, oh, we can't do it because there's a negative sitting over there, okay? But that's really not the case, because in this case, absolute value is not by itself yet. So we have to get absolute value by itself. I say isolate the absolute value. Get it by itself, okay? I got a minus 5 on that side of the absolute value. So I got to move that 5 over. So I'm going to add 5 to both sides. So I get the absolute value of 2x minus 1 equals 2. Once I'm to this point, and now it's equal to a positive, now I can set my two equations up. So we don't set the two equations up until the absolute value is all by itself. So we're going to do 2x minus 1 equals 2. 2x minus 1 equals negative 2. So we add 1, divide by 2. And same thing here. Add 1, divide by 2. And those would be our two answers. Okay, we're going to get fractions from time to time. All right, this next one, there's a lot of things on this next one that a lot of people make mistakes on. So I want to kind of talk about this one a little bit. Okay, once again, absolute value is not by itself yet. We want to get it there, okay? So anything that's on the outside of the absolute value, then we got to get rid of it. In some cases, the absolute value confuses people, I think, sometimes. I could rewrite the equation like this without an absolute value, and that might give me a better idea of the steps I would do. But the one thing that I will warn you on here is you do not distribute through an absolute value. It's not a parenthesis, okay? And it doesn't act like a parenthesis. So we cannot distribute throughout an absolute value. If you try to distribute through an absolute value, that will throw off your entire answer, okay? So we can't, if we have a number directly in front or a negative directly in front, we can't treat it like a parenthesis, okay? It's a completely different symbol because it's an operation. Absolute value is an operation. It's evaluating differently. So we can't distribute it. So if I give you an equation like this, what would we do first? how would I get x by itself here? Minus 7, yeah. And it's the same thing here. Because what we're trying to do is we're trying to isolate the absolute value, okay? So all I did here was just rewrite it without the absolute value. If I see it like this, I think it makes a little bit more sense to say, I know what to do here, and it would be very similar to what we have here. Leave the absolute value alone for right now. Get rid of everything on the outside. Now, we could treat that as like a -1 right there. There's no coefficient in front of it. So we think of it as a -1. And we got to get rid of it, so we're going to divide by -1. Because we can't distribute, so we're going to divide by it. That gets my absolute value by itself. And over here we have a +1. Both of those are good things, right? We can now do this. And now we will do our two equations. 2x minus 1 equals 1. 2x minus 1 equals -1. X equals 1. X equals 0. And those would be our two solutions. Okay. Once again, it would be something, this would be fairly simple to check because we don't have fractions or anything like that. So plugging it back in wouldn't be that too big of a deal. All right, one more equation I want to show you, and then we'll move on to the inequality part of absolute value. Okay, just like the rest, if we have absolute value and I have something on the outside of that absolute value, I want to get that absolute value all by itself. So the first thing I would have to do to get the absolute value by itself here would be to do what? -5. Okay, move that 5 over. So that gives me the absolute value of 3x plus 2 equals -4. Okay, and right here is where you have to kind of keep reminding yourself. If I have absolute value all by itself, and I see a negative number over here, we can just stop right now, okay? If you tried to set up two equations from here and try to solve those out, those answers are not going to work, okay? And I'm just trying to tell you right now, save yourself a bunch of time, pay attention, take your time as you're solving it. If I ever see absolute value equal to a negative, then right away I'm saying no solution. I can stop right now, okay? But what happens is we get in a big hurry sometimes. We just want to solve, we want to get it done, and we go through it all, and then I get two answers, and it looks like I get two answers. Like what some people would do here is they would do 3x plus 2 equals -4, 3x plus 2 equals +4. They would solve those two, but neither one of those solutions are going to work. And that would be another reason why I would encourage you to check. Okay, if we check, then when I plug it back in, I'll realize that, hey, these answers aren't working for some reason, right? So that's why you got to be really, really careful. Okay, questions on equations with absolute value? Okay, the next thing is we're going to look at inequalities. And so this is going to be very, very similar. But because we're going to be writing out two inequalities when we do these, we're going to have to decide, are we going to use and or are we going to use or? Because whenever we do compound inequalities, those are our two options. And so and means they're going to connect. The word that we use that goes along with and is both. What numbers are true for both inequalities? Or we use the word either that goes along with it. Okay. And we saw some compound inequalities before, but here we're seeing it with our absolute value inequalities. Okay, so I'm going to start off with a real basic one. absolute value of x is less than or equal to 2. We're going to set this up just like we did with the equations. The only difference is we have a less than or equal to symbol. Okay, and so that does change things. But when we set this up, x is less than or equal to 2. We rewrite the exact same one without the inequality, or without the absolute value. And then when we do the second one, just like we did with the equations, we're going to do one with -2. But here's the thing you got to be careful with. Because we have an inequality now, and we made this a -2, it's just like multiplying or dividing by a -2, which means I'm going to have to flip my sign. But then I got to decide which of these two words we're going to put in there. Is it going to be an and, or is it going to be an or statement? Well, there's a little trick that we're going to use, and this trick only works with absolute value inequalities. And so if my original symbol is less than or equal to, then what I say is less than, okay? And that helps me to remember that if it's less than, it's an and, okay? Less than will always be an and statement. So in between these two, I put the word and. Okay? So it's just a little trick to help us out. Now, what we're going to do here is we're going to graph our inequality, and then we're going to write our answer in interval notation. There's that interval notation again, because we have inequalities. I like to do the number line first. Make sure you put -2 on the left and +2 on the right, because negative numbers are further to the left. Positive numbers are further to the right. At -2, it's greater than or equal to. So here we got to remember our symbols again. This is going to be a bracket opening to the right. Less than or equal to +2 would be a bracket opening to the left. And we're going to shade everything in between. Most of the time, when I have an and graph is going to meet one another in the middle, okay? That's not true 100% of the time, but majority of the time, ands are going to meet in the middle. You're going to have one coming this way, you're going to have one coming this way, and they're going to meet each other in the middle. When I write my interval notation here, it would look like that. -2 to +2, including both of those. Okay. The other one that we could see. Absolute value of x plus 6 is greater than 10. Okay, I'm going to write out my two statements once again. The first one is exactly the same thing without the absolute value in it. X plus 6 is greater than 10. The second one is x plus 6, and because we're changing this to a negative, we're going to flip our sign to less than. So x plus 6 is less than -10. So always remember, when we do the negative one, the sign will always flip every single time. Okay, the trick here spelled a little bit differently, right? But great or. Instead of greater, we say great or, because when it's greater than, we think or. Okay, so less than is always and, greater is greater than is always or. Okay, so we're going to put an or statement in between these two. Those two tricks only work with absolute value inequalities. They doesn't work anywhere else. So we don't use those two tricks very often. Ors will typically go opposite directions. So ands are going to meet in the middle majority of the time. Ors will typically go opposite directions of one another. So I kind of remember it as or and opposite, O and O. Once again, it's not true 100% of the time, but majority of the time, that should be the case. I'm going to solve both of these out. X is greater than 4, or X is less than negative 16. We're going to graph it, and we're going to write our answer in interval notation. This time it's not equal to, it's just less than. So I'm going to do a parenthesis shaded to the left, and then a parenthesis shaded to the right. And those two are going away from one another. They're going opposite directions. Hey, and it's been a while since we've done this, but when we do our interval notation here, kind of like when we've done domain like this before. Remember, this goes all the way to negative infinity. So we're going to say negative infinity all the way up to negative 16. And that's why I like doing the number line first, is because now I can just say, okay, I'm going to start all the way here up to negative 16. But then we have that gap in there. There's no shading for a while. So that's where we put the little U symbol in between, kind of link the two together. And then we're going to start over again at 4, and we'll go to positive infinity on the right. And that would be our interval notation. Okay, so that's just the trick you got to remember, okay? All of these are very similar to what we did with equations, except less than or greater than are the two symbols you got to watch out for. All right, one last thing I want to finish up with, and then I start working on your assignment. If I said the absolute value of x is less than negative 3, okay? Inequalities are a little bit different, a little bit weird. So on this one, if I wrote it out like this, it's less than, so it's an and statement. If I were to graph this, remember that and must meet, okay? We're looking for what values of x are less than negative 3 and at the same time is also greater than positive 3. What numbers would be true for both of those inequalities? There's no overlap, right? And if there's no overlap, here we would simply say there's no solution. There's no numbers that make that work. Okay. But what would be different here is if I change the sign to greater than, my two inequalities would be x greater than negative 5, or, because it's greater than, so great or, x is less than positive 5. If we graph this one, negative 5's down here, positive 5's up here. What a lot of people would say is it's everything from negative 5 to positive 5, right? But that would be if this was an and statement. This is not an and statement, this is an or statement. So we're wanting to know what numbers are greater than negative 5 or less than positive 5. So if I picked out a number like 6, that would be down here, is 6 going to satisfy this inequality? Is it bigger than negative 5? Yeah, okay? Do we even care if it's less than positive 5? No, it only has to work for one of them, okay? Doesn't have to work for both, one or the other. If I did negative 6 wouldn't work here, but it would work here, right? So what numbers would work for this inequality? Everything, okay? And so we would say all reals. Everything works. If our interval notation, we would say negative infinity, positive infinity. Okay, so those are like two extreme situations, and I told you that and most of the time will meet, not always, okay? Ors most of the time will go opposite. Here they're going opposite, but they also overlap each other. So just a couple of different scenarios that I wanted to show you. There's some other things that you could run into. I'm not going to give you every single scenario that you could see, but most of the ones that you're going to see, or should go opposite, ands will meet in the middle, or you have these two special scenarios as well. Okay, the test on Tuesday and the review will be very similar, but it'll look very similar to our quiz, except these last 2 days will be added in. And it might be a little bit heavier on these last 2 days since we already took a quiz over the first 3 sections, but we'll have some of the things from the first 3 sections on there still, obviously, as well, but then we'll add in the rational equations and the absolute value equations and inequalities as well. Okay. So work on those over the weekend.